Hi, I'm Steve Ward. I'm a pre-sales consultant at Emerson, and in this slide deck I'm going to take you through our pack systems range of IPCs and displays. This will predominantly be a technical overview, but I'll also include some commercial aspects as well. First, a safety moment. Safety is very important. Emerson is very concerned with safety, both at an individual and at a corporate level. Key aspects involving staying safe and reviewing your working environment for issues before you start work, and you're empowered to stop work if it's unsafe. If there are any issues or near misses, report them and follow these 12 life-saving behaviours. I have a separate deck that covers the full Pack Systems, Movicon and Package portfolio. So in this slide deck, we'll be focusing on the section that's in green. So typically these are industrial PCs, and the industrial PC market has two main aspects. There's the market for the actual core server itself, which is the processing engine. That's typically used for data gateways, data collection, local analytics, and maybe even for industrial control. And then there's a similar but separate market for display type products. So you could use an IPC as a server for HMI SCADA and then have a remote client. You could also, in theory, connect an industrial monitor via HDMI or DisplayPort and USB for a mouse or keyboard or touchscreen. But there's also an option there to have what we call a display product, where you have the industrial monitor and industrial PC combined. So in that case, it's a single product to display, and it can fulfill the purposes of an operator interface, which is higher up in the portfolio, but it is also a computer product in its own right, because typically it would be Windows based. So we're going to focus on this section and explain about the characteristics and features and benefits of our Pack Systems industrial PC range and the RXi display range. Now, before we start, I'm going to have a bit of background about what is an industrial PC. And a good way to think of an industrial PC is to compare it with a commercial computer. Now, the commercial computer market is also split. You have it split several ways. You have high-powered desktops or workstations, you have laptop computers, and you have server-grade computers. Industrial PCs can combine several of those aspects with a flat screen display with an embedded CPU. You could have a server-grade industrial PC that's based on server type components. You also have that standalone sort of workstation type device, and that also is what the industrial PC can function as. But generally, if you look at a commercial computer, they have many restrictions, and the key one is they're designed for office environments. Laptops might be a bit more rugged. Servers might actually be less rugged because they're intended to be installed in a server cabinet where there will be a controlled environment. But typically, if you look at a commercial computer, it's designed for a narrow range of temperatures. So typically 10 degrees to 40 degrees C. Performance often reduces as temperature goes up. And if you do any sort of computer gaming, or if you do heavy loading on a creative type workstation where maybe you're developing video, you'll see that as the temperature of the CPU rises, then the performance reduces. Alternatively, you have to use special techniques to keep the temperature down, such as very large fans, and you'll hear that those fans go very loud because they're running very fast as the temperature is kept under control. Now, a commercial computer may have limited or no shock and vibration protection. Laptops are slightly better, but even then, their sustained shock and vibration capabilities aren't huge. And the key difference, of course, is that these commercial computers are based around commercial grade components. So if you compare that with an industrial PC, these are designed for industrial environments. The standard IEC 61131 Part 2 standard talks about 0 to 60 degrees. But for some applications, including marine, and also in some environments such as the Middle East, you need higher temperatures, and you also might need, depending where you're going, lower temperatures. So you can find industrial PCs that are rated from -40 up to +70 degrees C. Another difference is that they need to be performing 100% even at full temperature, but without having to have some very complicated management using fans. Now you will see some industrial PCs using fans, and they might have a reduced temperature rating below 60 degrees C, so you may need a fan for some applications, but the key aim is that we have an industrial PC with no fans, but it can still maintain 100% performance at full temperature. Now, one of the reasons for not having fans is it's a moving part, and that affects the MTBF, but also as a moving part, it has shock and vibration liabilities, and that can reduce the life of the industrial PC. So an industrial PC needs to be very good, again with the IEC 61131 Part 2 standard, you need to really conform with that. So you need that shock and vibration performance, and maybe even going beyond IEC 61131 Part 2 for very high levels of shock and vibration performance. Another difference is using industrial grade components. So these can help us achieve those higher and lower temperatures, and they can also be more rugged, and the industrial grade components can also extend to the actual housing. You can have a much more rugged housing, whereas a commercial grade computer is often designed for maintainability, and it's relatively low cost and easy to get inside, whereas an industrial PC might be much more of a sealed device, which reflects its industrial usage. So again, compare with a commercial computer, you do have those fans, but they reduce the MTBF. Even a really good fan running at 7 hours or 8 hours a day for say 5 days a week, it's probably going to fail after 3 to 5 years. Whereas with an industrial PC, we need a much longer life. So what we do with industrial PCs is aim to have no moving parts at all, and that gives us a much longer MTBF without having to do any sort of service work. And this also leads into a long design life. Industrial PCs are designed for an operating life of up to 10 years. There may be restrictions because of the operating system, but I have seen industrial PCs in use for many, many years, whereas a commercial computer, typically the design life is only about 3 years from launch. They may last 4 years or sometimes 5 years, and in an office environment they may well last longer because they're not being used very much. But it's partly that long design life, again, that's based on 24/7 operation. If you had a commercial computer running at 24/7, it's probably not going to last that long. I have seen laptops as well. For example, some companies lease their laptops, and we often see that the laptops, because they get treated very harshly, they do tend to fail after 3 to 4 years. Some may last longer, but the design life is not that long, and again, that's without a 24/7 operation. Now, another nice thing about industrial PCs is they have a fixed configuration. This is great for OEMs who want to install software and not have to worry about revalidating it every time a new operating system comes out, or a new chip comes out with a new driver, or a new CPU with new operating system support. That fixed configuration for that long design life is also very important. And that's very different from commercial computers. I used to run a PC bundling business, and I would buy computers from Dell, and they would vary not just from year to year or month to month, but even from day to day. You could even find that you'd order several computers in the same batch, and they might have slightly different components. So that might be minor from a commercial point of view, because it doesn't matter what the sound chip is, or it doesn't really matter what the Ethernet chip is, as long as it's supported by the operating system and as long as it gives you the performance you need. But for an OEM looking for a fixed configuration, that would be very complicated, because they'd have to revalidate their design for every single component change. And even if the varying configuration is not that much of a problem for an IT department, it can still be an issue even for large organizations, because then you have to think about storing multiple images for all of those different modules. So it can complicate even a commercial IT team that want to have a standard load for all of the PCs they offer. So varying configuration is a pretty bad thing for an industrial PC, and it's also complicated by the smaller teams that industrial PC users tend to have. Now, if you look at the operating systems, commercial computers often come with a commercial operating system, often loaded with bloatware, particularly if you buy retail. You'll find there are trials for Microsoft Office, there's trials for virus scanners, there might be games pre-installed, it might be configured to automatically download updates, and that commercial OS needs a lot of management to turn it into something that's suitable for embedded or OEM use. So with industrial PCs, we tend to use an embedded version of the commercial operating system or an OEM version. And that one, first of all, it has longer term support. So we use the LTSC version of Microsoft Windows, for example. And also with those versions, they have the option for the OEM to remove components that aren't required. And in many cases, you can also turn off automatic Windows updates. So that means that, again, for that fixed configuration, the OEM knows what they're going to get without having to worry about what update was installed and do I have to revalidate all of my applications. Now, commercial computers, obviously laptops and workstations, are desk mounted, servers are rack mounted, and that's not particularly suitable for industrial applications where normally we want panel mounting and or DIN rail mounting. So that's another difference with industrial PCs, the physical mounting. And the last one here is power. Industrial PCs ideally run off a low power 24 volt power supply because that's what you've got in the panel or the cabinet. It's a nice low voltage supply, it's nice and safe compared to a commercial computer that typically needs to plug into a mains outlet. Servers are slightly different because a lot of servers run off mains power, but there is a move to lower voltage DC supply so that you can move the power supply away from the server and have a higher grade power supply for your rack of servers. But that's quite an esoteric thing, and it doesn't necessarily apply to all servers. So again, that power supply, the industrial mounting, the industrial capabilities, all of those apply in industrial PCs, but commercial computers are used in very different environments. So the summary really is that commercial computers lack the ruggedness and the long life that industry requires. So industrial PCs, they may cost slightly more to begin with, but the return on investment and the overall cost of ownership, generally it would be lower than using an equivalent commercial computer. So here are some application examples. We have typical industries that use industrial PCs, for example, semiconductor manufacturing, additive manufacturing, process automation, machine builders and OEMs, marine applications. Typically that's ships and yachts, but it may also include other marine applications, including offshore oil and gas. And there are multiple industries where industrial PCs are used, and they have specific requirements. They need high reliability, they need high levels of availability to avoid costly downtime. And you might think they're the same, but they're not. High reliability is normally about avoiding failures, but high availability is about not needing to be maintained and shut down and restarted frequently. Some of that's an aspect of the operating system, but high availability, being able to run your computers for as long as possible without a restart and without having to do updates, is very important. Now, these systems may need high performance, not always. Generally, we find that in commercial environments, the computer is sitting around not doing very much for most of the time, but there are times when suddenly it launches into action and does a lot of work. So one of the application differences with industry is the high performance. It might not be the peak performance we need, but we do need sustained high performance to manage the loads that we're operating. You also need low latency. The computer needs to be able to respond in time according to the requirements of the machine or process. And typically, that's why you have an industrial PC in the first place. It is mounted and installed close to the machine or process. It may need expansion capability, so you might want to improve the graphics, you might want to add a neural processing unit for AI loads, you might want to add field bus interfaces. So there are requirements for industrial PCs that are similar to more workstation type PLCs or PCs. But that expansion capability, that's very variable depending on the application. But they do need to be rugged. Again, you might get high or low temperature, you might get high levels of shock, high levels of vibration. And then the final one here is you need that long life with fixed configuration. You don't want to have to buy a new unit as a spare and find that it's completely different to the one that it's replacing. Again, we find that with commercial computers. The form factors change, the operating system changes, the chips that are used inside change. Whereas being able to buy a replacement after several years that has the exact same configuration is really useful for OEMs and end users. So let's take a closer look at industrial PCs and panel PCs. So Emerson's offering for industrial PCs and panel PCs includes both of those types of systems, and there's also a crossover. So in general, as I mentioned, you split the market into the raw underlying compute unit, which could be a small gateway, it might be a more powerful analytic computer, it might be a HMI SCADA server. And then you have those panel PCs, which include the computer and are able to have an all-in-one unit that mounts directly into a panel. But there is a possibility for an overlap in the middle where you could use a high-performance PC with a HDMI or DisplayPort to an industrial monitor. So we cover all those bases with our range of industrial PCs and panel PCs. So they're powerful, expandable units. They're also highly reliable, and they're designed for industrial use at the edge of the network alongside the application that they're monitoring and controlling. And the same with the displays, designed to be suitable for all of those aspects we saw for use by the industrial PCs. So high and low temperature. Another thing you need is maybe ATEX if you're using it in an explosive environment, typically ATEX Zone 2. If you have a panel mount device, it needs to have very good panel mounting with typically IP65+, and we can achieve that. And then there's also the low voltage 24 volt operation and all the other aspects you need. So our IPCs are designed and manufactured in our German manufacturing facility, which is in Augsburg. And this is a centre of excellence. Originally it was based on military and aerospace type computers as well as rugged industrial computers, also used in the telecoms industry. So highly reliable devices that are able to provide high performance computing, and that's both for analytics at the edge but also for enhancing any real-time control application. What we've developed in Emerson is a patented thermal monitoring technology with sophisticated passive cooling that gives us high levels of reliability but also ensures that full performance at maximum temperature. Now the way we do that is a patented device, and the idea is that particularly for the IPCs, the case is actually the heatsink. So you'll see there for the one in the middle, the IPC 6010, it's a very solid rugged aluminium case and it has lots of vanes. And what we do is we sandwich the electronics between the inner and outer coatings, and we have those vanes to actually remove the heat. The panel itself can also remove heat, so you'll see later that for the highest temperature ratings, panel mounting is preferred. Now, in order to get a good contact between the CPU and the memory components and so on into the actual heatsink device, the way we do that is we've got special technology which allows us to get very good contact. The reason that's required is if you've got a normal CPU, then when you solder that onto the board, and all our components are soldered on, then when you solder that components, sometimes you can get a slightly different level, which means if you were trying to bond directly onto a heatsink using an embedded enclosure like this, then the heatsink might not have full and proper coverage of the actual chip that it's trying to cool down. So our patented technology makes sure that regardless of the orientation of the CPU and the other chips, then we get good thermal transfer to the enclosure and also onto the panel, which means that we can get that very good performance even at those high temperatures. It's also passive cooling, no fans. You'll see later for some of our units there is a fan option for very high temperatures, but that's optional and not always required. And the idea is that we can run up to full temperature without any fans and also then maintain that full performance. The idea is with these designs, these offer enhanced productivity and lower total cost of ownership. And again, they have a long design life. We're aiming for a 5 to 10 year design life, and we have a published product lifecycle policy which explains how this equipment is supplied. You are relying to some extent on the operating system vendor, but that would depend more on how your network is architected and how you configure things like firewalls and cybersecurity as to whether you can continue to use the operating system or not. But the hardware does have that very long life, but with that ongoing supply. And that's one of the reasons why we use embedded industrial components, because we can guarantee the supply of those for much longer than you can for, say, commercial components. So we have a wide range. We have a small micro IPC, the IPC 2010. We have the RXi 2BP, which is an older design now based on an AMD Ryzen CPU, still available, but in many ways superseded by our next generation PC, which has three part numbers. There's the IPC 6010, 7010 and 8010. And the reason we have the three part numbers is for different sizes of TDP and the amount of power that we can dissipate for those particular boxes. And that also decides the performance of the CPUs that we can use. Now the RXi 2BP has been around for about 5 years, Still available, still a good device, but the key reason we're replacing with the IPC 6010, it's not because the RXi 2BP and its chip is going away, it's more because, in common with many computer related items, you get more money or more performance for less money. So the RXi 2BP will continue to be available for existing users in line with our product lifecycle policy, but in terms of price and performance, it's blown away by the IPC 6010. Now we also have the monitor solution. We have an RXi industrial monitor, and that goes from 7 to 24 inches. That uses DisplayPort and HDMI. It's also got DisplayPort pass-through for multiple monitors, and it's also got a multi-touch touchscreen. And then we use that identical display technology, but with an AMD Ryzen CPU mounted behind, and that turns the device into a panel PC available in 12 to 24 inch sizes. So we'll talk about the applications that these cover. There's also a big crossover with Movicon, which is our HMI SCADA, and another big crossover with Package, which is our industrial Internet of Things solution. So they're more on the software side. But yeah, there is certainly a crossover between the pure hardware and the range of applications that we can support as Emerson using our Edge and HMI SCADA products. So let's start with displays. Now we introduced this concept in 2019, and we run Plant Engineering's Product of the Year Silver Award for this concept. The idea is to take a shared set of screens, so it's the same screens regardless of what sort of product they go into, and then we have this so-called backing module which mounts on the back of the screen using an industrial connector, and then the backing module provides the functionality for your final product. So by using an AV module, then we can achieve the requirements for an industrial monitor. By using a web-based device, which is a low-powered industrial PC running Yocto Linux and a Chromium browser, we can have a web panel. And then by adding a full-blown computer-type backing module onto the screen, that gives us the capability of creating a full-blown panel PC. So it gives us a very modular solution. It means that it reduces the amount of complexity we have in our supply chain, so we can have simplification in terms of how we offer these products. It also gives you a degree of replaceability and maintainability, and potentially you could even upgrade in the field, although that's complicated because of the way the approvals work. But potentially you could go from, say, a web panel, and you could upgrade that to a panel PC just by replacing the backing module. What's more realistic, I think, is if you get a damaged screen, then you could keep your backing module and just replace the screen, and that would allow you to simplify your operations by not having to replace or reinstall an operating system and all of its applications. So it's a shared set of screens. They go 7, 10, 12, 15, 19 and 24 inches. In the 7 to 15 inch range, we also have a sunlight readable display, which has much higher brightness, up to 1000 nits, and also that one has a coating as well, an anti-reflective coating, making it suitable for use where there is a high levels of sunlight. So outdoor sunlight readable display, we call that. Now each screen includes an integrated light sensor, so you can have automatic screen brightness, so it auto adjusts to the environment. That can be turned off. We've also got very good dimmability levels. So for marine applications, we can actually dim these down to almost near zero brightness. So they are useful for use on board ships' bridges, as well as for inside the ship for other applications. There's an LED indicator, which can be used to display in 3 colors. So amber, green and red, and that can be controlled by the application. It also helps you display or detect if there's a failed module. Each of these screens, they come in a variety of different resolutions. They're all widescreen, but they also include a 10-point projective capacitive touchscreen, and that supports gestures and intuitive operations in compatible applications. The fronts are all glass. That protects against scratching from knives, keys and steel tools. And we also have very good chemical and fluid resistance. And as I mentioned, when these are front mounted in the panel, these can achieve IP65 very easily. On the backing module, we have a variety of capabilities and connections. For the RXi Panel PC, we have a powerful Ryzen-based CPU, and then this has a very good set of connections. So we've got 4 gigabit Ethernet ports, we've got an RS232 and an RS485 port, We've got two USB 3 and two USB 2 ports. We've got a display port connection, so you can drive a second or subsequent monitors. We've also got a mic in and a line out connector, so you can do audio visual work. And then you've also got there a 24 volt DC power supply connector as well. For the web panel is designed to run HTML5 web browser only. So this one has a much smaller subset of connections and a lower powered processor. It's got one Ethernet, which allows you to connect onto the network. It's got an RS232 port, which could be used as a local console, but otherwise not really used. It's got USB 2 connection for connecting a keyboard or a mouse. But remember, the screen has got a full multi-touch screen. And it's also got another USB port, an on-the-go USB port, which is used for firmware updates. For the industrial monitor, this has got one HDMI in port, it's got a display in port, it's got a display port output port, it's got a touch output, which is your USB port, and it's got line out, so you can have sound coming in to the monitor via HDMI or display port, and then the line out could be used to connect to the external speakers if needed. Again, you've got the 24 volt DC connector there as well for power. So range of choices, using the same set of screens from 7 up to 24 inches, depending on the type of PC you get. We can either do a display only for connection to a commercial or industrial PC. We can do a web panel for kiosk and web-based applications, or we can have a full-blown panel PC using a relatively powerful Ryzen CPU that allows us to run a full-blown HMI SCADA server and client. So we'll come on to industrial PCs in a minute, which is where you might use the industrial monitor. But from an industrial PC with a panel point of view, we have the RXi Panel PC range. So again, this was part of the Product of the Year award from Plant Engineering. And the idea here is we're using an AMD Ryzen CPU. It's a V1404, which is the high and low temperature version of the AMD CPU. It's a quad-core chip between 2 and 3 gigahertz, and it has a benchmark performance of around about 6,000. Now, to give you an idea of what that means, a typical laptop has a similar sort of benchmark. Maybe some of the very newer ones, which are marketed as AI type laptops, have a bit more power. But for most laptops that you would see in use in the field, you're looking at a benchmark of between 5 and 8,000. So this benchmark of 6,000 here, this gives you a good idea that it's going to give you very good performance in line with a standard sort of laptop that you would come across in day-to-day use. Screen sizes, they start at 12 inch and go up to 24 inch. And again, we've got that outdoor SLR option on the 12 and 15 inch versions. For me, the sweet spot is about the 15 inch because that's a good size with good resolution. But we find increasingly users are demanding larger and larger screens. So that's why we offer the 19 and 24 inch options. Now, the AMD CPU, that's backed up with 8 or 16 gigabytes of RAM. So 8 gigabytes would be ideal for, say, a Movicon client, whereas maybe 16 gigabytes would be as if you want to combine Movicon server and client. And for other applications, it's going to depend on what the application requires. For storage, we have SSDs. We use SSDs for reliability and ruggedness, no more moving hard disks. And they're available in sizes of 128, 256 and 512 gigabytes. There's also a micro SD expansion option. Now, many people try and cut costs by using the smallest storage device. Again, if you had a Movicon client, 128 gigabytes would be fine. I would say if you're doing any sort of server work, then you should go for a much larger hard disk. There's two reasons for that. One is, of course, you might be wanting to store data. So having a larger hard disk means you won't run out of disk space. But also, the larger a hard disk, when you're writing to the hard disk, then the SSD performs wear leveling. And the idea is the larger your hard disk, the greater the load can be shared across the total SSD chips that are used inside the SSD device. So larger devices tend to have a longer life when you're writing to them. So I would say 128 for a client. And if you've got a server and client, then you probably want to go for 512. Maybe if you wanted to economize, maybe you've got a server that's not doing much data storage, then 256 might work. Again, you've always got the option of using micro SD for expansion, but often micro SDs aren't ruggedized, but they do give you the option for transporting data between two devices. Of course, you could always use a USB memory stick for that as well. And the other thing is your micro SD could be used for offline storage of data outside of the actual PC device itself. For these, the operating environment is -30 to 65 degrees C. We run Windows 10 IoT Enterprise LTSC software. You might say, well, Windows 10 was discontinued in October. That's not strictly true. With the LTSC version that we supply, this one is based on Windows 10 2019 LTSC, which is supported until 2029, and we're looking at upgrades for later versions to be supported until 2032. If you wanted to, you could potentially run Windows 11 on this. A big downside of Windows 11 for industrial users is that Windows 11 needs a Microsoft username. So now you're having to link this in with a Microsoft account, or possibly link it to Active Directory or domain. And also with Windows 11, it likes to connect to the internet for updates. So a lot of users still using Windows 10 at the industrial panel level because it can be a standalone device and it doesn't need that Windows or Microsoft account. And again, with the Windows 10 IoT Enterprise LTSC version, it is identical to standard commercial Windows 10, except it has the built-in long-term support until 2029, and it also has all of the bloatware removed. So no games, it doesn't do automatic Windows updates. You have to run those manually if you want to. And a lot of the other bloatware that's in a standard computer, it doesn't have. In terms of interfaces, we did see some of those, but I'll run through them again. So we've got 4 10100 1000 base T RJ45 ports. They are separate ports, so you can have up to 4 independent IP addresses. It's got an RS232 and an RS485 port for serial communications. It's got 4 USB ports, 2 of those are USB 2 and 2 of those are USB 3. There's a DisplayPort output to connect an extra monitor if needed. And using DisplayPort daisy chaining, potentially we can drive up to 4 monitors with this one device. And you've got the audio visual support with microphone in and line out. So very good device. And again, using those screens, it has got the built-in touchscreen support with the multi-touch. So this is an ideal single device for panel mounting for HMI SCADA, and it gives you a very high level of protection. It gives you that good glass screen with the protection against chemicals and protection against scratches, and it's a great device. And also, because it's modular, remember, if the display does fail or is broken or damaged, you can replace the display but keep the backing module. So that reduces the costs of maintaining your systems because you don't have to buy a complete new unit, but it also reduces the installation and data recovery time. So a very innovative design, good life ahead, and a very good product with good performance to run HMI SCADA client and server type applications. Let's move on to the IPCs. This is the PAC Systems IPC 2010, which is our entry-level, cost-effective ARM-based IPC. So ARM is a low-cost CISC-type CPU. We use the A53 as our base model, and that's available with either dual or quad core. The speed is limited to 1.2 GHz, and this gives us a benchmark of around about 200 to 250, which is significantly less than the 5,000 you'd expect from a typical modern laptop. But for the purposes we need, this is very adequate. We have a very small footprint here. You can see from the size of the Ethernet ports, this is actually a very compact design, about 30 to 40 millimeters wide, about 100 or so millimeters high. DIN rail mounting, and it's intended mainly to be used as a gateway device. Could be used as a low-cost industrial PC for edge connectivity applications, maybe for simple machine level analytics, possibly for performing some sort of control, but really it's more intended for the low-cost edge gateway type solutions. So this is supplied as standard with our package stack running on top of Ubuntu Linux. So this is where we have a crossover between the industrial PC hardware and the package IoT solution. So go and have a look at my package slide deck if you want to learn more about how package works. So with this one, the memory, it's either 2 GB with the dual core or 4 GB with the quad core. Generally this has 64 GB with an SSD, and there's also micro SD expansion, and there are also USB ports, so you could also plug in a USB device if you wanted to. Now, operating environment is -20 to +65. And this one, as we mentioned, the operating system is Linux with package and then all of the package applications, but you could just use it as a Linux device as well and run your own solutions. You don't have to use package if you've already got your own software stack. But take a look at that package slide deck to see what that means. In general, what package does is it gives you predefined, pre-configured, pre-installed application development tools to allow you to create your edge solution. But as I said, you can use your own, you don't have to use ours. Now, from a hardware point of view, this gives us reasonable performance. One nice benefit is that with the Linux operating system, you're not running all of the user interface that Windows requires. So 250 doesn't sound like much, but we can still get reasonable throughput for data collection and analytics type applications. This could easily achieve 200 to 300 values a second for data logging or some sort of data gateway type application. In terms of the interfaces, we've got two separate Ethernet ports there. So that's two independent IP addresses and they're gigabit Ethernet ports. We've got an RS-232 serial port. We've got two USB ports. We've also got a USB-C port, which is actually a custom USB-C for DisplayPort output. So you can plug in the local monitor. And there's an optional LTE GSM modem and Wi-Fi and Bluetooth connectivity option if required. Now, in terms of the DisplayPort output, you can drive a monitor. I'd say with the dual core, we don't recommend that because you don't really have enough performance. It will drive a monitor. It will allow you to plug in a keyboard and mouse. You could run the graphical user interface with Linux, but you'd get very poor performance because the CPU would effectively max out in terms of performance just driving the display. You could drive just using a terminal-based display, that would work fine. But really, if you want to use the local monitor capability, I'd say you need to step up to the quad-core version with the extra 2 GB of RAM, and that gives you additional horsepower sufficient to actually run a graphical user interface. However, this device isn't really intended for that. It's more intended as a headless device, but certainly for diagnostics and configuration and setup, you could connect a local monitor if you wanted to. And the performance, I'd say it's adequate. It's not blindingly fast, but compared to some legacy type operator interface products and applications, it's reasonable, it does work. So ideally, this is used for machine level analytics and edge connectivity applications. You could also use it to run a local web HMI. So it could be a low level HMI server using a web-based interface. And depending on your application, potentially this could even run a local graphical user interface as well. So a very nice device, and the key point, very low cost. The entry level price of this is low enough that it's quite a low price and it doesn't impact on your operation of your machine or your plant, and it doesn't increase the loading or price on top of your machine level price. So very good for these cost effective and cost sensitive applications where you do need a low cost device. Now I'm going to skip the RXi2 BP, that's still available. We have the older RXi2 EP, XP and UP ranges. The RXi2 EP is now discontinued because that uses older generation AMD CPUs. The RXi2 XP is based on 6th generation Intel CPUs, which are effectively discontinued now, although we still can supply that for legacy users if really required. But I think that will go end of life soon. We've got the RXi2 UP, which is the ultimate performance one, and that's based on Intel 7th generation CPUs. So again, really at the end of its life, and the 7th gen and older CPUs have cybersecurity issues with latest operating systems. So I don't recommend the use of those older ones. But testament to their life, they are still available and just coming to their end of lives at about the 8, 9, 10 year mark. So they have had a long life. They are due for replacement in terms of technology, but we have been able to achieve that 10-year life and even ongoing for some users. But where we are today is our next generation IPCs that we introduced earlier in 2025. And these are very modern, using the latest industrial versions of Intel 13th generation CPUs. Now, we talked about the benchmark of a typical laptop being in the order of 5,000 to 8,000. That's where these CPUs start. We start at about 8,000 for the entry level device, and we go up to about 22,000 for the high-end device. So the reason we can do that is these modern Intel 13th generation CPUs have had a big jump in performance over older CPUs. First of all, you've got more cores. The way Intel do this, they have a combination of high performance cores, and there aren't many of those. You might only have 2 high performance cores, but to allow you to run parallel operations, they also combine lots of efficiency cores. So the idea is if you're doing some high performance application, you can use the performance core, but if there's a low priority application going on in the background, maybe a virus scan or some sort of update or something else that's going on, that can use one of the efficiency cores. And that allows you to have high performance, but without impacting the overall critical applications that are running on those CPUs. Having said that, with the high-end CPUs, they do have a lot more cores. Another aspect as well is that these CPUs have a much bigger cache memory. So particularly the level 3 cache, which is the last cache level before you go out to the outside RAM, that's very large. That also improves performance. But we've also got high-speed memory as well. The high-speed memory also aids performance. So we go from 8 up to 64 gigabytes of RAM, depending on the model. And we've also got very high-speed memory connection to the storage device. So we've got a variety of different storage devices. We start at 128 gigabyte SSD, and we can go up to 1 terabyte or possibly even more. I think some devices now are even bigger than this. And optionally, you can have a micro SD card for offline storage, and you can also use those USB ports. Now for cybersecurity, these latest Intel 13th Gen CPUs have very good cybersecurity, and we also include the Trusted Platform module. So this gives us compliance with the latest operating systems, and the Trusted Platform module is used to store security keys and certificates. So that's used as part of the overlying operating system, including things like Secure Boot and Trusted Boot. It's all based around the UEFI operating system and bootloader, and Windows 10 and 11 particularly, needs a Trusted Platform module in order to be secure. Now the standard operating temperature is 0 to 70, although it depends a bit on the model. We'll have a look in a bit more detail later, but we do offer a -40 to +70 version as well, using a high and low temperature version of these Intel 13th generation CPUs. There's a choice of operating systems. We have Windows 10, and again it's the IoT Enterprise LTSC version. This is actually the 2021 version, which is supported until 2032. You could also use Linux. You could use your own operating system, and very soon we'll also have Windows IoT 2024 SKUs as well. Windows IoT 2024, better known to most people as Windows 11, but that's the IoT version, which means that again you can reduce and remove all of that bloatware, and you can remove the automatic Windows updates and make it more suitable for use in industrial applications. However, as I'm aware, Windows IoT 2024 still needs a Microsoft account, so it might not be ideal for every user. And Windows IoT 2024 doesn't have the long-term service channel. So Windows 10 LTSC is available until 2032. Funnily enough, the Windows IoT 2024 version only has a standard 5 years support. So that's actually only until 2029. So funnily enough, you get longer support with Windows 10 than Windows 11, but that may change depending on Microsoft's future arrangement and support for these different operating systems. Now, the whole idea of the Next Generation IPC is to improve everything. So as well as having these high performance CPUs with high performance memory and the larger high performance SSDs, we also have 5 Ethernet ports, and they're 2.5 gigabit Ethernet ports. We've increased the number of serial ports, so you've got 2 RS-232 and 2 RS-422/485 serial ports. Not every application will need them, but for the few that do, it's nice to know they're built in. We've got 6 USB ports, so that's a combination of USB 2, USB 3 and USB-C. On the USB-C ports, we also have Thunderbolt support. So the idea with those USB-C ports, they are USB-C, but they can also be used to connect monitors. And we're the only industrial PC vendor that has that Thunderbolt support using those USB-C ports. We also have 2 separate DisplayPort++ connections, and that gives us a total of connecting up to 4 monitors, either individual connections using the USB-C and DisplayPort connectors, or you could use USB to multiple devices using some sort of bridge or hub. You also can use the DisplayPort option with daisy port chaining, and you could either use one DisplayPort output to up to 4 monitors or 2 DisplayPorts with 2 monitors each, but we do support up to 4 monitors with this hardware. Now there's an optional LTE or GSM modem which can be built in, and we also have Wi-Fi and Bluetooth wireless connectivity options as well, again built in, and that can use external antennas which are connected via antenna connectors, which would be optional on the module but would be on top of the unit where you see those black holes at the top there. We also support PCIe expansion. There's a choice of either no PCIe expansion, or you can have a riser board that gives you options for 1, 2, 3 or 4 PCIe expansion slots. Now there are some limits with what you can do with those expansion slots because you're limited on the overall power, but it gives you the ability to run external cards for additional interfaces, maybe additional cards for additional sorts of data storage, maybe some sort of AI or other expansion capability. And we also have some optional extras, including a Halo artificial intelligence neural processing unit. So these units are ideal for premium, critical and large scale applications with high performance. So ideal for running a HMI SCADA server, ideal for running high performance analytics applications, all the way from an analytical model using machine learning up to a full digital twin, but also for any other sort of high performance computing requirements. But the entry level price, even if you don't need all of that performance, the entry level price is still very good on the lowest units. So even if you're not using all of those performance, these are also very good units from a cost effectiveness point of view. Now a note about the part numbers. We've got 3 different models, and the reason is we've got the 6010, 7010 and the 8010 designations. That refers to the TDP capabilities we have with the different hardware and CPU sizes. So the 6010 is actually a slightly more smaller enclosure than you see here. The 6010, that can support TDPs of up to 15 watts. So that means you can typically run various Intel 13th generation CPUs with this TDP of up to 15 watts, and that's typically with a benchmark of around 5 to 10,000. If we go up to the IPC 7010, that has a TDP capability of 28 watts. So this gives us a more intermediate capability, going from about 10,000 up to about 15,000 or so for the benchmark. And the 8010 gives us 45 watts, so that means we can go from about 13,000 or so up to the full 22,000. So that's where you get your highest levels of responsiveness, but of course those units do cost a bit more. But this gives us a good level of scalability across a wide range of applications, and if you don't need all of that performance, then you've got the option of going for lower cost models, which give you very good cost effectiveness for applications which maybe aren't quite as intensive. Now, key point about these, there's no moving parts. There is an optional fan, but that's only for very high temperature operation. But for the majority of applications, you don't need any external components. There's no moving parts, very rugged, and we've got that patented technology to remove the heat. Another thing on the reliability and the ruggedness side is everything is soldered. So the CPU is soldered, the memory chips are all soldered. So again, that helps us with our ruggedness, with the capability for high levels of shock and vibration. Let's do a deep dive into the PAC Systems IPC 6010, 7010, 8010. That's a bit of a mouthful, so I'm going to try and refer to it as the Next Generation IPC, but the words are interchangeable. So the new PAC Systems Next Generation IPC comes in 3 different models with 2 different form factors. We have the IPC 6010, which is the lowest power version, also known as a slimline, and this uses Intel 13th generation U-series CPUs which have a TDP of 15 watts. This is the one you can see on the left. The IPC 6010 has a slightly smaller form factor. The one on the right is the IPC 7010, and the 8010 have the same form factor. So with the IPC 7010, this we're referring to as our advanced model, and this uses Intel 13th generation P-series CPUs with a TDP of 28 watts. And then the IPC 8010 is the flagship or high-end version, and this is using Intel 13th generation H-series CPUs with a TDP of 45 watts. So you can go and look at the Intel pages if you want to get a comparison of those different CPUs. The idea is there's a wide range of different CPU choices with different amounts of cores, different amounts of efficiency and performance cores, different amounts of L3 cache, and of course different price levels, but with varying different levels of performance accordingly. This is our IPC advantage. We offer high reliability, superior performance, and an extended life cycle, all based on our extensive knowledge from military and aerospace applications, and all developed in Europe in our Augsburg headquarters, which is our centre of excellence for industrial PCs. As we've talked about, what the users need from an IPC, it needs to be ruggedized for industry. So we've got very good robustness. We've got fanless capability with no moving parts. We've got high quality standards with 100% functional testing and thermal connection testing. And we've got very good cybersecurity as well, partly aided by the latest UEFI BIOS, along with that trusted platform module, and of course in conjunction with the operating systems you use. In terms of price to performance ratio, these give you superior performance with 100 CPU performance across the entire temperature range using that patented thermal design and testing processes that we use. And on the extended lifecycle front, we have multiple years of hands-free operation with extended availability and support, but also easy upgrade capabilities as well. And these new IPCs, they're a big technology leap for Emerson. We've adopted 13th generation Intel industrial CPUs. We have soldered memory using low profile DDR5 6400 DRAM. We use 64 gigabit NVMe SSDs ranging in size from 128 gigabytes up to 4 terabytes. We have a 40 gigabit USB-C with Thunderbolt connectivity capability. There's an AI capable GPU based on the 13th generation CPUs, but we also have this option for an AI neural processor unit as well. With the Ethernet capability, we include time synchronous computing ability with TSN, which is time series networking. We have the latest 2.5 gigabits per second Ethernet. For Wi-Fi, we're supporting Wi-Fi 6 and 6E. On the PCIe side, it's PCI Express 5 with up to 32 gigabits per second throughput. We can enable a discrete GPU via PCIe as well, although in practice that might be limited by the TDP of the box. We've got the state-of-the-art cybersecurity, again with the TDP, the TPM, and the latest operating systems in the UEFI support. 15 to 45 watts in one single design, and with comparison to our previous RXi2 range, we've got a 41% reduction in the 2D footprint and a 58% reduction in the 3D volume compared to those previous models. So it's a big technology leap in a very compact system that's very rugged and very reliable. So here's an overview of the Emerson IPCs and the comparison of the key functional specifications. So on the IPC 2010 side, starting with the CPU, it's an ARM A53 with 2 or 4 cores running at 1.2 gigahertz. And it's a very low power design with a TDP, a thermal design power of only 4 watts. Moving up to the RXi 2BP, which is still available, but no longer promoted as such because it's superseded by the later IPC 6010. This is an x86, x64 compatible CPU based on AMD Ryzen, so 2 to 4 cores. We have a maximum frequency of up to 3.6 gigahertz, and this is using a 15 watt TDP design. Now if we move up to the IPC 6010, this is using the latest Intel chips, and now we have an x86, x64 compatible design as before, but now we have more total cores. So with the lowest levels, there's 5 cores, but with the larger ones we can go up to 10 cores, and the frequency is significantly improved up to 4.9 gigahertz. So along with improved level 3 cache, it's still only 15 watts, but this gives us a significant improvement in performance over the RXi 2BP, but the actual cost price is less. So that's why we see that the IPC 6010 will take over from the RXi 2BP, because why would you buy a slower, older model that costs more when you can get a newer, faster model that costs less? Now moving up to the IPC 7010, Again, the same Intel x86, x64 capability. This time we go from 8 to 14 cores depending on CPU. Maximum speed is 4.8 gigahertz, and we have up to 28 watts on the TDP. And it's the extra TDP that gives us the facility to run multiple cores side by side, and that's where you get your improved benchmarking performance from. And then the flagship IPC 8010, again x86, x64 compatible, 8 to 14 cores, but now we're going up to 5 gigahertz, so we've got a slight speed improvement, we've got bigger level 3 cache, and now we go up to 45 watts. So again, that's where you get your performance boost with that larger TDP and the ability to use more of the processor cores at higher speeds. Now, these devices, in terms of a built-in GPU, the IPC 2010 has a very low power GPU, but it's not really anything to write home about, but it is enough to be able to control an external display. When we move up to the RXi 2BP, this does have a display port option, and you can use this for display purposes. But when we move up to the IPC 6010, 7010 and 8010 range, you've got this display capability, but now that GPU is also powerful enough to be used for AI acceleration, and the GPU itself is also faster and more powerful if you're looking at graphics intensive applications. In terms of memory, we start off at 2 or 4 gigabytes on the IPC 2010 with typically a 64 gigabyte SSD. There is a 32 gigabyte SSD option on a very low powered unit, but we don't really promote that one. With the RXi 2BP, 4 to 16 gigabytes of RAM, but when we move up to the IPC 6010, 7010 and 8010, we've got much larger memory sizes going from 4 or 8 and up to 64 gigabytes of RAM. Hard disk sizes also increase in terms of sizes. So we go from 128 to 512 gigabyte on the RXi 2BP, but on the IPC 6010 we've got much larger sizes at the high end, going up to 1 terabyte or even 4 terabytes on the largest models. We've talked about interfaces, so with the Ethernet interfaces we've added an extra port and we've improved the performance to 2.5 gigabits. We've got more USB ports, including that USB-C capability. We've got additional DisplayPort capability as well as that USB-C with Thunderbolt, and we've enhanced the amount of serial ports. Again, don't see the use for serial ports too much, but they can be a bit of a challenge for some applications, so the ability to have built-in serial ports does solve a lot of problems. Now we do have expansion capability. With the IPC 6010 upwards, we have M.2 slots which can be used for storage, for Wi-Fi and for AI accelerators. And there's up to 4 of those M.2 slots that can be used for a variety of different applications. And we've also got additional PCIe slots. So with the IPC 2010, that's not really expandable. With the RXi 2BP, you could have 1 PCIe slot. But with the IPC 6010, that can support 1 PCIe slot as well, using an optional add-on daughter board. With the IPC 7010, we can go up to 3 PCI slots using an add-on daughter board. And with the IPC 8010, we can go up to 4 PCIe slots using that add-on daughter board. Now, the IPC 2010, you can do cellular or Wi-Fi, but that's an add-on device. For RXi 2BP, there's that choice of either the add-on device or you could use a built-in Wi-Fi, which has got some certifications. And then we've got that same built-in Wi-Fi for the IPC 6010, 7010, 8010, and we can also use cellular or Wi-Fi with an add-on device. Operating temperatures vary across the range. Standards is 40 up to about 60 degrees C. There are some reduced options there on some of the very higher ones. So for example, with the IPC 6010, the maximum is 70 degrees without a fan. With the IPC 7010, we can go up to 65 degrees C without a fan, but there is an optional fan to achieve 70 degrees. And for the IPC 8010, we can go up to 60 degrees, again up to 70 with an optional fan. But that gives us very high levels of temperature for your industrial applications. And there's also some derating that might need to be applied as well for using the PCIe slots, but I'll come on to that in the next few slides. So on this slide, we see an overview of the different parts available. Of course, we've got the IPC 6010, 7010 and 8010 base units. So you've got low power and slim, you've got advanced and the high end, with TDPs of 15, 28 and 45. And if you want to do extensions, the way that works is we have a set of IPC expansion slot modules. So with the IPC 6010, you can use the 1 slot expansion. With the IPC 7010, you can use the 1, 2 or 3 slot expansion. And with the IPC 8010, you can use the 1, 2, 3 or 4 slot expansion units. Now these units, they come as standard with a VESA mount. If you're using the VESA mount, that enables you to use a direct panel mounting. But we also have an optional DIN rail mounting kit and a panel mounting kit. Panel mounting is preferred because that gives you the most rugged support, but it also gives you a better temperature transfer from the unit to the panel itself, and that gives you potentially higher temperature ratings. But DIN rail is probably easier for many applications. And there's also this fan accessory unit. So the fan accessory unit gives you the capability of running the highest temperatures. So there's a variety of different add-on modules there, depending on, do you need PCIe slots? Do you want to run at the full 70 degrees C? And how do you actually want to mount your unit to the panel itself? Here's some detail of the top of the unit, and we're looking at this obliquely so you can see all of the connections. So starting off on the left-hand side, we have the power supply connection for 24 volt DC power. The next connector along is for connecting in the fan unit. So the fan unit is directly controlled from the IPC itself. And the idea is the fan unit only kicks in at the very highest temperatures. You don't need it for the lower temperatures. It just kicks in when needed. You've then got your 2 DisplayPort plus connections, and that includes the DisplayPort daisy chaining. You've then got 2 RS232 ports. You've then got 2 RS422485 ports, and those ports are isolated. And then moving round to the front of the unit, if it was typically mounted on its back as we would expect, then you can see that we've got the 4 standard Ethernet ports. So they are 2.5 gigabit base T Ethernet ports. They do support TSN, and they've also got LED indicators on them to tell you whether they're connected and whether it's a simplex or duplex type connection. And then we've got a separate Ethernet port. This one has additional capabilities. So it's still a 2.5 gigabit base T Ethernet port, but this one includes capabilities for Wake on LAN, so you can have the unit automatically started remotely. It includes AMT remote management, so you can use that with AMT clients to manage the hardware. And it also supports TSN, and it's got those 2 LEDs to display the port status. Moving around again, we've got 4 USB ports. So these are USB 3.2 Type A connections. And then we've got a variety of LEDs and buttons to tell you what's going on with the unit. So there's a power button with an integrated status LED. There's status LEDs for telling you about disk and network activity. And there's also a physical presence button. The physical presence button is used for part of the cybersecurity. So the idea is some functions like accessing the BIOS and so on, you need to use the physical presence button. So that means there has to actually be someone there. So that disables any remote attack, because without someone pressing the physical presence button, then the remote attack will fail because you haven't got anyone to actually press the button to authorize the action. We've then got the Thunderbolt 4 ports, which are the USB-C ports. So they're combined USB-C with Thunderbolt 4 capability. And again, there's those additional LEDs. So your SSD activity, there's a temperature LED as well, a wireless connection, and the user-defined port as well that you can access through the operating system functions. And the last connection there's a cover for the micro SD card slot, so you can remove that cover and plug in a micro SD card. What you'll also see if you look at the top of the unit, you've got the label to indicate the part number. That glows in blue when it's powered up, but it's also the indicator for which model you have. And if you look behind that, further over to the top left there, you've got 2 screws. That's actually the cover for the PCIe connector. So underneath there, that would be where you'd plug on your daughter board for PCIe connections, and that would be expanded on this side. On the other side of the unit, that's where you've got the connections for the VESA mount, and that's also where you would screw in the fan if required. So you can have a fan connection and you can have PCIe modules, and they're mounted on different sides of the actual base unit, so that you can have your 70 degrees C support and you can also have PCIe expansion. Of course, if you're not using those, then we have a cover in place, so that protects the inside PCIe connections. And this is what the unit looks like with the cover removed. So this time we're going from right to left. You can see all the connections, starting off with a 24-volt power supply, moving through all of the connections, the serial ports, the Ethernet ports, the USB ports, the display port, and the LEDs and so on. Inside there you can also see a close-up of the CPU. So the CPU is that big long device that's on the right hand side around the middle, and you can also see the memory chips. The important thing to notice here is that all of these components are soldered onto the board. So this is what gives us the best level of shock and vibration support. Now you could argue there's a downside there that you can't change these in the field, and that's true. But what it does give you is very high levels of ruggedness compared to other industrial PCs that use SODIMM. With SODIMM, you've got a connector, and what we've seen under high levels of shock and vibration, those SODIMM connections, they can fail, and that reduces the life and the reliability of the unit, where everything we have is soldered onto the board for maximum levels of ruggedness and reliability. Here's the underside of the IPC circuit. So this will be with the lid removed. And what you can see here is some of the internal connections. So over on the left hand side, there's that PCIe connector for expanding with the PCIe ports. Looking at the top, you can see there we've got the optional wireless connections, and they go down to a wireless module. And then you can see underneath the wireless connections, we've got a full length and also half length MPCIe slot. So this is used to support the SSD. We've got an M2 M key as well with PCIe with 4 times connections. We've got an M2 E key which supports different types of expansion such as the Wi-Fi and also the Halo module. And there's also there a chassis intrusion button as well. And you'll also see underneath there you see a real-time clock support battery, which is a CR2032 type battery, which is used for storing the values for the real-time clock. Notice there the little pads, they're used for heat transport onto the case. So that's part of our connection to enable all the devices to be cooled down. And that big metal plate at the bottom there, that's part of the cooling and also the security connection for the CPU, which is mounted on the other side. So that's like a load spreader to spread the mechanical load, but also spread some of the heat load as well. Now we have a large number of units, so to simplify the configuration, we have a part number system, which is a modular arrangement of numbers and letters which you make up to build up the actual components you need. Now one thing to note is not every component or every product mix is available. We are planning to have as many available as possible in order to meet the largest number of requirements, but it may be that you could select a part number here that we don't physically manufacture. So if you wanted a part number that we don't manufacture, we can do that either via a special arrangement, and that would involve a volume purchase, or we could look at investigating to see if other people want that same configuration. But generally what you would do is you would use this for your initial product selection, and then we would align this with the actual products that we actually physically make. And one of the reasons we do that is if we were to make every single product, then the amount of variance would just be way too big. So every single order would be a special order, and that would increase lead times, it would increase complexity, it would cause problems with the agency certifications. So we're simplifying the portfolio, but also giving this part number selection capability, which just makes it easier to understand what the products are. So all of the part numbers start with RPB, and then we have a number. 6 would be for the 6010, which is the 15 watt low power units. 7 would be for the advanced 28 watt units, and 8 would be for the 8010 high-end 45 watt units. The next part number after that, which corresponds with the actual 6010, 7010, 8010 number, is the actual CPU we use. So this is the designation of the Intel 13th generation CPU, and here you've got the number of cores, both the performance cores and the efficiency cores, and also the CT and the ET, that refers to temperature. So CT is like standard temperature, ET is extended temperature. So you can see at the entry level we use the U300, which has got 1 performance core and 4 efficiency cores, but still achieves that very high level benchmark. And then we go up through a range of i3, i5, i7, which have more performance cores and more efficiency cores. Then we move up to the i7 range with the extended temperature, and then we go to the larger chips. So we start with the U range of chips, then we go to the P range of chips, and then we end up with the H range of chips. So you get higher levels of performance, and the maximum one there is the i7 13800 HRE, which has got 6 performance cores, 8 efficiency cores, and that one's also the extended temperature range, but you can also get that with standard temperature range as well with the HE designation. So the range of different CPUs, that gives you a range of different price points as well as performance points, so you can match your IPC compute power to the application that you need to solve. Now the next number along is the memory size. Again, not every memory size is available in every unit. We don't see why you would go for a really high performance CPU and then just have 4 gigabytes or maybe even 8 gigabytes of RAM. So some of these, you only have higher levels of RAM or maybe lower levels of RAM depending on the processor you're choosing. But you've got the available memory sizes there: 4, 8, 16, 32 and 64. And then we have some optional components. So the next number or letter here is, do you want non-volatile MRAM? So you can have no for no MRAM, or you can have 8 megabytes of MRAM. And the MRAM is used for non-volatile storage for critical operating parameters. So that might be used, for example, with an operating system and a control type system where you want to store values across a power fail, but you don't want to rely on using that flash memory. The next one is SSD. So you've got 0 for no SSD. Not sure why you'd want that one, so I don't think we've got any of those in the part number. And then we've got a variety of SSDs, again related to the size of the CPU and the size of the processor. You can have different SSD sizes, but not every single part is available for every single model range. But we do 128, 256, 512, 1 terabyte, 2 terabytes, and going up to 4 terabytes. The next letter refers to the operating system. So you can have no operating system and install your own. So you get the capability to boot off USB or the micro SD card or boot from a network and install an operating system yourself. Or you can have Windows IoT. So as I said, this is the Windows 10 Enterprise 2021 version. You can have package. So see my other slide deck about what package gives you, or you can just have Linux by itself. So that would normally be Ubuntu Linux with no other software. And as I mentioned, we're about to introduce the Windows IoT 2024 version, which is effectively the Windows 11 LTSC or the Windows 11 IoT version. There's then a variety of add-in modules. Again, we've got no add-ins. There's a Wi-Fi option. There's the AI module. There's NVRAM. And then there's a combination of 2 or all 3 of those, depending on which ones you need. And then the final letter is the ambient class. So this is the temperature rating. So we're referring here to the ambient air temperature outside of the CPU. So there's commercial temperature, so that's what CT stands for, at 0 to 70, although in my mind that's way beyond what a normal commercial application would be. But 0 to 70 is the standard temperature, and then we can go from -40 to 70 with the extended temperature range. One thing to note on the ambient classes, there may be restrictions based on which product line and which processor you use. You might not be able to get to the full 70 degrees, for example, on the IPC 8010, unless you're also using a fan. And I'll come on to for some of the temperature ratings in a later slide. Now, just to help, we've also got an online configurator, and I'll talk about that later. But one of the ideas is you can go online and then you can make your selection using our online configuration tool. And then that can give you a detailed report, and then we can pass that to our customer care team for quoting. So there is a nice easy way of doing this. You don't have to build up the part number manually. Another option is to use a spreadsheet that I've developed, which gives you a nice selection and being able to filter on different products and different options as well. Or of course you could just search. So if you work for Emerson, you can use our Salesforce CRM. Otherwise, you can talk to one of our sales representatives and they'll be able to help you choose the right part number for your application. Here are the part numbers for the PCIe expansion slots. So these begin RPE, and then we have a set of numbers which indicate, first of all, how many slots there are, 1, 2, 3 or 4 PCIe slots. The next one is more of an internal designation that refers to the internal part number of the PCIe riser. So we've got the PERC 41, 42, 43 and 44 that I'll go on into in a minute. And then you've got the PCIe card option. Currently this would be A for no PCIe card, but we're also investigating a RAID option as well to support RAID disks. Personally, I don't see the point in using RAID if you've got SSDs, but some specifications do ask for it, and there could be some use cases where RAID could be required. There's then a set of letters and numbers which we don't use, and then the final one is the ambient class, which is always F for -40 to +70 degrees C. So for example, if you've got an IPC 8010 and you need 4 PCIe slots, then you could use the RPE number with the PERC 44 card, no PCIe, and it would give you your extended temperature. Now in terms of these PCIe expansion slots, it is worth noticing the generation of PCIe with support and the number of lanes. So with the PERC 41 for the 1 PCIe expansion slot, it's a Gen 4 interface using 4 PCIe lanes. So this would be ideal for applications which require maybe a communications board, but it wouldn't give you enough power to drive a graphical expansion board or maybe a board that needs more power or needs more bandwidth. With the PERC 42, we've got a Gen 4x4, and we've also got a Gen 3 with 1 lane, so that's even more restricted. So again, ideal for some legacy communications modules, but not really suitable for high performance graphics or possibly other applications. With the PERC 43, it's 1 Gen 4x4 and 2 Gen 3x1. And it's only when you get up to the PERC 44 that we get a Gen 4x8 lane interface that gives you the capability to use newer, more modern boards with greater throughputs. So I would say you could potentially find a graphics board that would go in here, but it would be quite an interesting design. There would be physical space limitations, and another limitation is the amount of power that we can actually put out for the PCIe slots. So from my view, this is less about graphics capability, although that is a possibility, but it's more about running expansion cards for communications. So maybe if you need additional Ethernet ports, maybe if you need dedicated communication ports, maybe something like CAN bus or Profibus, there might be examples of where you use the PCIe expansion. Here are the details for mounting options. So as I mentioned, I prefer the panel mount kit. The panel mount kit gives you the best temperature transfer onto the panel, and this would allow you to also have the best shock and vibration capabilities. So for this one you need the panel mount kit, and that's typically a single part number, although if you're using some of the optional components you might need 2 of these to get full support for mounting onto the panel. We also have VESA support, so we're using the standard 100mm by 100mm connection with M6 screws. So this would allow you to bolt directly onto a panel, but you'd need to have 4 holes screwed through the panel to use those VESA ports. And then we also support DIN rail. DIN rail is probably the easiest one to mount, and for that one we've got a DIN rail mounting kit, and you might need 1 or 2 of those depending on which type of IPC and which expansion connections you've got. One thing to note on the VESA mount is those VESA mounts are also used to mount the fan, so if you're using the fan you can't use the VESA connection. And then you've got here a chart showing you all the different availabilities of the different mounting options. So IPC 6010, you would have the base unit using 1 DIN rail, and you could use VESA or panel mount, and then for the expansion unit that would also need its own DIN rail option. If you have the IPC 7010, then you can have up to 3 expansion slots again, so that gives you your suitability of your mounting connections. And then with the IPC 8010, then again you've got all the different mounting options and how many of the different kits you need. One thing to note here as well on the DIN rail side, DIN rail, it does reduce the temperature capability. It also reduces the shock and vibration capability. So again, my recommendation would be to use the panel mount kit, which gives you the best combination of temperature transfer to the panel as well as better shock and vibration characteristics. And here's a related chart showing you the different IPCs with the different temperature capabilities. So if you want the highest temperature, then you would use the IPC 6010 and you would use a panel mount or VESA mount, and that gives you up to 70 degrees C capability. That same panel mount is 65 degrees C with the IPC 7010 and 60 degrees with the IPC 8010. And then you can see we derate the temperature according to different mounting characteristics and also how many of the expansion slots you might be using. Of course, you can always go up to 70 degrees C if you need it by adding the fan assembly, but you just need to be careful there how you mount and how many PCI expansion slots you've got as what the maximum temperature is. But for the majority of applications using the IPC 6010 and 7010, we can achieve up to 60 degrees with no problem. And even for the IPC 8010, you have 50-55 degrees C. Remember, these are ambient air temperatures, so they're not the temperature of the unit itself, they're the temperature of the ambient air around the unit. So you could always use forced cooling inside your cabinet as an alternative to the fan. And if you have a very hot cabinet, then you might be looking at using some sort of air conditioning on the cabinet. Here's the limitation of the slot extensions. Each slot extension is limited to 25 watts. That's in total, not per individual PCIe slot. So again, that would limit you on the sorts of cards you could use. So low powered communication cards would be fine, but I think you'd struggle to find any graphics card which has only 25 watts consumption. And here's another matrix showing you the shock and vibration capabilities. So with DIN rail, we get the maximum of 15G shock and 1G vibration. If you use the VESA mounting, we can actually go even slightly higher than that. We can go 20G shock and 2G vibration. But if you use the DIN rail mount, then we're down to 10G shock and half a G vibration. So using that DIN rail does significantly reduce the amount of shock and vibration we can support. So for the best use, you've got either VESA or panel mount capability. Now, we do measure those vibrations and shock under standards. So for vibration, it's EN 6068-2-64, and you can see there that's random vibration in the 5 to 100 Hertz range at 0.04 G per Hertz. So that gives you that capability. And we do test these. We actually test on our own shock and vibration table, which we've got in our Augsburg facility. So these aren't calculated maximums. We do actually test these. So the test duration is 60 minutes in different axes, and we've got the calculation there for the different effective values. And on the shock side, it's EN 6068-2-27, so that's more of an impact shock. And again, we have a duration of impacts there. It's not a single impact, and there's different impacts in different directions with different durations and different acceleration and pulse shapes. So you can see there, these are the characteristics that we're using for the shock and vibration testing. As I said, we do actually perform our own shock and vibration testing. We do have these testing capabilities in our Augsburg facility, so we can be sure that all of these are real values that we have tested ourselves. We're not relying on an external agency to do this testing for us. Now, these devices are CE marked, but also UL marked. We also have ATEX, and these are the standards that apply. So we have the safety under the low voltage directive, and different directives there for the UL equivalents and the CSA equivalents. ATEX is zone 2, and again you can see you've got the UL equivalents and the Canada hazardous location equivalents. We're fully ROHS compliant, and we also support EMC compliance as well, so both under the European directives, and there you can also see the FCC equivalents. So these devices are fully compliant with the required standards. One thing I see coming up is the Cyber Resilience Act, so we will also be testing for the Cyber Resilience Act. I don't think that will have many applications in terms of changing the product. There may be some changes to the BIOS, but we will need to have the CRA compliance in order to have the continued CE marking. So that's something that we will be investigating. And for models that have the Wi-Fi option, they also meet other directives as well, which gives us the requirements again for FCC and for these European norms. Now I haven't put marine approvals on here. We're currently testing these units for marine approval. So the key marine approval there is DNV. DNV tends to be the harshest marine approval, and if we can meet that one, we know we can meet the others. But we're also planning some of the standard marine approvals. So DNV is our main one to go after, but also Lloyd's Register, ABS, and maybe some others. So they will follow when we've completed our marine testing, and that's probably due in early 2026. So here's a table of sizes and weights. You can see that they all have the same footprint, which is about 191 by 158 millimeters, about the size of an A5 paperback book. And then we have different widths depending on which model it is and whether you've got any PCIe expansion slots. So the slimmest unit is 44 millimeters wide. That goes up to 60 millimeters on the IPC 7010 and 8010, and it increases accordingly with a few extra millimeters for the PCIe slots. Notice the weights. The weights on these units is surprisingly heavy, and that's because these units are constructed mostly of a solid piece of aluminium which forms the heatsink for the unit itself. So the units are quite heavy because the unit is also its own heatsink. So we go from 2.1 kilograms for the smallest devices up to almost 4 kilograms, which is the IPC 8010 with the 4 expansion slots. So that's also why we have the shock and vibration characteristics, and they're best using either VESA mount or panel mount. It's because these units are relatively heavy. Now the power supply is 24 volts DC. We start at 3 amps on the standard IPC 2010, and that's the peak current during startup. Typically without extensions, then you're normally looking at 2 amps during normal operation, but it could be anywhere between 1.6 and 5 amps. For these units, I'd recommend a 5 amp as a minimum power supply, and ideally you might be looking at 10 amps. You might get away with a 4 amp power supply, and we've got some suggested power supply part numbers that we can supply as Emerson. These are our SVL power supplies, which is the value line, but we've also got the more powerful and the better specified SDNC power supplies as well, which can do 5, 10 and increasing sizes. The IPC 7010 and 8010, because of their higher TDPs, have a higher current, and that would be the peak current up to 5 amps peak, but you've also got a higher current with the extension slots as well. So you've got to think about what your power supply is going to be, because this could be quite a heavy load. As I say, I'd recommend minimum 5 amps. More likely a 10 amps would give you lots of headroom in order to supply this with anything else. Here are the details of the fan assembly. So you can see there for both sides of the fan, it's a 120 millimeters fan, hence the part number RPF 120. 120 millimeter fan that forces air over the vanes on the grayer side of the unit, whereas the blue side is where we do the PCIe expansion. But this forces air over the major heatsink part of the unit, and the idea is this mounts onto the VESA module and it gives us the forced cooling at higher temperatures. Now the fan won't turn on all the time, it will only turn on when the unit gets very hot, but this allows us to increase the temperature of operation up to 70 degrees C. Now I would avoid using a fan if possible. We do use as reliable a fan as we can find, but the issue with using a fan is that it will have a limited life compared to the rest of the unit, and also you've got the potential for contamination. So what you might find is after a few years, if you're not doing any regular maintenance and blowing out the fan, then you might find that it seizes up, and that could find that your suddenly your 70 degrees C operation that you had before now drops down to as low as 50 degrees C, so you might have problems in future. So avoid using the fan if possible, but if you really want those highest temperatures, then the fan is there as an option. Now a key point about the Next Generation IPC range is the use of these Intel 13th generation CPUs. We can also mention that these new IPCs are designed for artificial intelligence workloads. So we have a combination of characteristics that enable them to be used for AI type applications. So typically when we talk about AI, We could be referring to LLM type applications, large language models, but more likely we're talking about machine learning type applications using TensorFlow and similar applications. So we have a range of high performance CPU cores. So you've got the CPU itself, which has low latency and is suitable for lower compute AI workloads. You've got a built-in high performance GPU, which you can use for split use. It has both the option of a graphical output, but you can also use that GPU as an AI acceleration to offload AI tasks from the CPU itself. And for the fastest performance, you've got the option of a plug-in low-power M.2 neural processing unit. So those modules include Halo and Google Coral. These are for smaller workloads with very low power and small size applications, but they do give you significant throughput improvements for certain AI loads. Optionally, you could also plug in an AI NPU module using PCIe, so that might be for higher performance applications. And you could also potentially use a GPU, although having done some research on that on myself, that there's a big limit to the number of GPUs that you'd be able to find that would fit within our environmental constraints. But AI is very popular for machine learning and for other industrial automation use cases. For example, we can do vision applications, quality inspection, safety improvement, remote automated monitoring, predictive maintenance, and also process analytics and quality assessments. And the reason for using a rugged IPC for these AI workloads is that they are close to the machine, so that gives you very low latency, and it also allows you to have higher data bandwidth. So this is much better than a cloud-based solution. Because it's on-premise or on-machine, you can get that higher performance and higher speed and better results. Because it's local, it also gives you data privacy and security. The data is not traveling out into the cloud, so it can't be hacked because it remains local. And also for remote sites, because all the data is local, that can also reduce the costs of data transmission. Again, because it's an on-premise installation, you're not sending data through a remote network, so that significantly reduces your amount of data, and obviously that reduces the potential costs of that data. So definitely designed for AI workloads, particularly around these machine learning AI type applications that we've mentioned here. So this is an example of an NPU acceleration module. So NPU is neural processing unit, and these are specialized chips that are designed to run large numbers of calculations in parallel. So they are AI accelerator modules specifically intended for AI applications. So the one you see here is the Halo 8. So you can see it's a very small M.2 module with low power consumption. It's only 2.5 watts. But it does give you this very high AI throughput at low power and gives you very good efficiency compared to using a GPU. And the reason we've got these NPUs and also using a GPU is a lot of artificial intelligence relies on running multiple parallel operations at very high speed. And if you put that through a normal CPU, then you haven't got that high level of multiple support. Because you've only got maybe 8 cores, you can only do 8 things at once. But a GPU can be much better because you can have up to, say, 96 or 128 graphical processing units. But with an NPU, you get even more processing units. Each individual processing unit is lower powered, but because you've got so much more of them operating in parallel, that allows you to do your operating tasks. So if you look at the Halo 8, this is ideal for AI applications including TensorFlow that I mentioned, Keras is another one, PyTorch and Onyx, these are example AI applications. So what you would do is you would use one of these as a toolkit, and you would use that to build your machine learning model, and then you would have inputs that go through the NPU using that model that you've built, and that would give you an output. So for example, you could use that to detect a shape using vision intelligence, and then you could also do it for things like barcode reading and other applications. And then the output of that could be used to control the flow on the conveyor or some similar sorts of applications. Now, the way we measure artificial intelligence speed is through tera operations per second, or TOPS, and this particular Halo 8 NPU can reach 26 teraops. So very fast processing, ideal for real-time image recognition. Can also be used for natural language processing, but I don't see much of an application for that in industry, but also very much for neural network inference, which could be used for things like digital twins. This is what our online configurator looks like. The purpose of having an online configurator is to help you build up the part number of all the different combinations available. So you start by going to the high level of the online configurator and you select the IPC model based on its CPU class, 15, 28 or 45 watts. From there, you can then select the CPU type, you can select how many PCIe expansions there are, you can select things like the memory, the SSD card and so on. You can add in optional hardware modules. You can then select the operating system, and at the end of that it gives you a report which is the part number along with all the configuration details that you've selected. So ideal for people that maybe don't have the understanding of exactly what they want. It takes you through all of the different characteristics, and then the output is giving you all of the technical information as well as the part number information. And you can see there on the technical side that includes things like dimensional drawings. There's a 3D CAD download, and with the configurator you can create these as projects so you can keep them on our server and you can log in and then recreate your previous configuration or retrieve your previous configuration, so you don't have to do it all from scratch every time you use the configurator. Here's an example of the report output. You can see you have the base part number. It gives you a breakdown of the modules. It gives you details of any additional extensions. It includes details of mounting options and fans, and then it gives you the final data ratings for the size, the weight and the overall ambient temperature rating. Now the only thing is, because there's such a wide range of potential IPC models available, we are choosing to implement a core subset first. So not everything that the configurator gives you is actually capable of being ordered. So what will happen is we expect that the output of the configuration document will be sent to a technical specialist like me, and what we will do is we will validate that part number, and if it's not available we will be able to advise you on a similar configuration that is available. It's also possible that we might improve the online configurator in future to only allow you selection of ones that we are manufacturing, but that's something that we are looking at. But that's something that's continually evolving as well, because as we ramp up production of these units, we are adding more and more modules. So at the moment, we don't want to limit it too much. One of the ideas of having the configurator as well is to find out what units people are requesting, so we can see that maybe we actually adopt that as a model. Even if it isn't previously manufactured, we could start manufacturing it if the demand is there. So let's quickly summarize. The key points about our industrial PCs is we've got rugged, high-performance IPCs for a wide range of applications. Again, check out the package slide because that covers edge applications. We've also got the capability of performing control using third-party control engines, and we've also got the option to run the system as a HMI client, HMI SCADA client or HMI SCADA server. So lots of different applications that we can run there, including many other industrial PC type applications that I might not have covered. From our point of view, one of the key issues is that we can offer 100% performance at maximum rated temperature, and that's something that a lot of our competitors don't do. As their units get hotter, they start to slow down. And that's very poor for deterministic applications, but it can also be quite poor for applications where users are looking for immediate responsiveness. So by having that 100% performance at maximum temperature means that regardless of what you're doing, the system will still respond as required. Another aspect is long life with fixed configuration, so ideal for OEMs who don't want to keep revalidating their configurations. They can use the fixed hardware configuration, and that means that their software will always work through the life of the product. This is also an ideal add-on to our Movicon sales. So with Movicon we have a HMI SCADA, and the idea there is that you can use our IPCs as a way of running our Movicon software and get very good performance. And if you're doing that, of course, you can also add on an industrial monitor, and we can also supply power supplies and switches as options. I've now got some backup slides with a bit more additional information that you might find interesting. You don't have to listen to these are optional, but there is some useful snippets in here. First thing that's interesting is the potential performance improvements over our previous models. So if you look at the entry-level IPC 6010 compared to our previous RXi 2BP, these are both 15 watt class units, but what we have with the IPC 6010 is 1.5 times the compute performance, 1.5 times the graphics rendering speed, 2.5 times the memory throughput, 5 times the storage throughput, 8 times the expansion bandwidth, up to 2.5 times the Ethernet speed, and 4 times the USB speed. What's really interesting to me is that the RXi 2BP in its day was one of the fastest industrial PCs in its price range, and even today it's still very attractive as a unit, but it's significantly outclassed by the IPC 6010, and this has occurred within about 5 years. You know, the advantage of using those Intel CPUs, the 13th generation CPUs, over and above what was the older AMD Ryzen that's used in the RXi 2BPs, there's been significant improvements in those last few years. Something else that's really interesting as well is that the IPC 6010 model with this improved performance is coming in at just over half the price of the RXi 2BP. So not only have we significantly improved the performance, we've managed to reduce the price, which means that those performance enhancements are even more exciting because of the cost price performance ratio. That's increased not by 1.5 times, but we've increased it by something like 3 times. So the actual performance improvement versus price is even more impressive. If you look at the IPC 8010 over the previous RXi 2UP, these are a 45 watt class CPU, and previously we're using chips either 7th gen Intel CPUs, either Xeon type chips or Intel i7 type chips, and now we've moved up to the equivalent 13th generation Intel CPUs, and this again we've got significant improvements in performance. We've got 3 times compute performance, 3 times graphics rendering, 2.5 times the memory throughput, 5 times the storage throughput, 6 times the expansion bandwidth, 2.5 times the Ethernet speed, and 4 times the USB speed, and again at a significant cost reduction. The typical IPC 8010 to get this level of performance is again about half the price of the RXi 2UP. So that means that from a cost performance ratio, these numbers are actually doubled. So we're getting 6 times the compute performance if you look at the price per performance ratio. So significant performance improvements enabled by a combination of our Emerson technology along with these Intel 13th generation CPUs. There is a Wi-Fi option, and for this we're using the Intel AX210 Wi-Fi module, which is Intel's recommendation for our 13th generation CPUs. This supports up to Wi-Fi 6E, and what we have with this is 2.4 GHz, 5 GHz and a new 6 GHz band with Wi-Fi connected by a PCIe backplane. The benefit of using these multiple bands means that we get better throughput, and with the 6 GHz range, this is also less congested, so it opens up better throughput in certain environments. It does mean that the range is reduced, but in certain applications that can mean that you get much higher throughput compared to the previous 2.4 and 5 GHz bands. It also supports Bluetooth 5.3 with a Bluetooth connection per USB 2. And then what we would do with this module is it would fit in one of the 2 available M.2 E key slots. And we've got a dual antenna design with that, again for like MIMO, multi-in, multi-out type, beam-forming type applications. And again, that gives you very good coverage. The dual antennas, they're connected via external connections because, of course, the IPC would normally be in an industrial enclosure, and they often act as very good Faraday cages. So what you would do is you would wire your antenna externally on the actual enclosure itself, or maybe even take the antenna higher up to give you even better coverage within your industrial environment. Here are some details of the LEDs and buttons. First of all, you have the power LED that's also a button, so you can use this to turn the unit on, You can also use it to reset the unit by holding it down for 4 seconds or more. You can also use it for putting it in standby or hibernate mode, and the colour changes according to what state the device is in. So red is for the system is in off. Yellow would mean that the system is in sleeping or hibernation mode, and green would mean that the system is up and running, and of course off means that no power is applied. We've also got a mass storage unit. This flashes green whenever there is storage activity. Typically that's anything using that M2 device. So any access of that M2 device and the storage activity LED would flash. That one's just an LED, not a button. There's a temperature LED. Green is okay underneath the maximum temperature. Yellow if you're approaching the maximum, and that could also initiate a graceful shutdown of the operating system. And then red, that would indicate an immediate shutdown has occurred if the temperature went very high above the critical hot temperature. Again, that one's an LED. We have a Wi-Fi LED. Because we've got an internal M.2 E-key or MPCIe slot for Wi-Fi, then of course you can't see what the actual Wi-Fi module is doing. So we've got an external indicator here, and this is using a blue LED, again LED only, but it indicates Wi-Fi activity. There's also a user controlled LED. This can be green or red, and this is implemented by the user through operating system support. So this would depend on what application you're running, but it allows the user to have control. And then you've also got this physical presence LED, which is also a button. This one is used to unlock the system or act as a physical presence device. And the idea of this one is to work with various operating system and BIOS states to allow you to do things like clear the TPM or install new certificates or update certain aspects. And the idea, again, from a cybersecurity point of view, you prevent hacking remotely by forcing the user to be physically present at the device. So you actually have to be in front of the device in order to be able to update it. So any remote control type attack or man in the middle type attack is disabled because no one will be present at that device to press the button. We do have lots of detailed documentation. There's a high-level data sheet. We have the Declaration of Conformity for the European Union. We have an Installation and Maintenance Requirements Manual. There's an Important Product Information or README type file. We've got a detailed hardware manual. We've got product-related drawings that cover the mechanical aspects of the systems. Internally, we also use what's called a product update notification. This contains what's in the important product information, but also might include something that's for internal Emerson use only. So if you're outside Emerson, you won't see this. And even if you're inside Emerson, it's not normally worth referring to because the pertinent information is already included inside the IPI. And then there's two more documents. There's a quick start guide. The quick start guide is for users that want to get started quickly without reading the complete details of the hardware manual. It gives you all the information you need to get it plugged in and started up. And then for people worried about cybersecurity, we also have a secure deployment guide which details how to secure the items against cybersecurity attacks. Here's an example of what the mechanical drawing looks like. So you've got here an overview of all the physical dimensions, and it includes all of the connections, how the unit is mounted, along with details of all of the connections. So this could be a big time saver because you can include this in your own drawing package without having to manually draw this separately. And then we have more installation details. So here's the installation detail for how you connect the fan assembly. This effectively splits apart into two sections, and then one section is screwed into the VESA sockets, and then you clip it back together, and then you connect the fan using that dedicated fan connector, and then the fan will operate to cool the device when required. Notice that, as we said, the fan does use those VESA connections, so that would mean you can't install this using the VESA connections. You'd have to use a DIN rail or a panel mount connector using one of those R2B accessory units. And here's the details for installation of PCIe cards. So you've got 1, 2, 3 or 4 slots, and this details how you can remove blanking plates. It details how the modules are installed and also then how the modules are actually secured. And because this is designed for industrial applications, we have additional mounting beyond what you'd normally expect with a standard commercial PC. So there's this additional stabilizer option which you can use to stabilize the module and keep it in place, and also improve the shock and vibration characteristics. And finally, we have the details of how to get into the BIOS. So what you need to do is connect to keyboard, and then when you start the unit, you would have to press delete or the function 2 key, and then during startup, that would allow you to enter the BIOS. Once you're in the BIOS, you've got the capabilities to select the boot source. You can select boot priorities in case there are multiple boot sources. You can configure hibernation and sleep states. You can configure passwords. So of course, for cybersecurity purposes, you can enable that the UEFI BIOS can't be changed without entering a password. And you can also configure secure boot. And when you've finished, you can save changes by going to the save and exit page and then save changes and use the exit option. So the BIOS is used to change various operating parameters. Not often required to go into the BIOS, but you have got that capability to do that. A key one would be there to set passwords. Again, interestingly, if you look at the Cyber Resilience Act, one of the things the Cyber Resilience Act says is that you have to have more passwords and you're not allowed to use default passwords. So it could be that one of the outcomes of the Cyber Resilience Act is that you have to go in and configure a UEFI password before you can use the unit. But that remains to be seen, and that may or may not come into place depending on what the provisions of the CRA are once we've finished our technical assessment. And also, as this in the industrial device, there may be different requirements compared to a consumer device. I know it's very common these days to buy a consumer device like a router, and the first thing it asks you to do is change passwords. Also, that's what operating systems do. So for example, when you enter the Windows 10 setup or Windows 11 setup, it asks you to set default passwords. So it would be similar sort of approach, but of course this is relying on the underlying BIOS hardware rather than the actual installation of whatever it is we do. So that could be an upcoming change you see in future revisions of the unit.